Hello. Today we're going to try and determine a vehicle's speed simply by looking at its wheels. We decided to take video of a bike rolling past with a marker in its wheel so that we could use it as a reference point to find the angle it spun through. We placed the marker in the front wheel of the bicycle, and here is a video of an example. Now that we have a reference point in our video, we can use it to determine the velocity of the bike itself. Watch the next clip carefully in order to determine how fast the bike is going. Did you see that? Feel free to go back if you need more time to record observations. Now the first thing you're going to do in order to complete this problem is to figure out which lens you're going to need. Of course, the lens for this problem will be kinematics, because kinematics gives us the equation for velocity, which is v is equal to dl over dt. In English, this means that the velocity is equal to the change in angular momentum over the change in time. This can also be described as the second derivative of the angle times the radius over the second derivative of the time. This is more commonly written as d squared theta times r over dt squared, as currently shown here. Once you have that written down, the next step, of course, is to draw a picture. So we will begin by drawing two different pictures of the bike at two different points in time. As for which 2 points in time, we decided to take one full rotation of the wheel and determine the change in time from the beginning to the end. So here's some stills from that video. As you can see, it's on the left side at a time we set equal to 0 seconds, and it's again on that same spot on the left side 0.77 seconds later, so we know the change in time for one revolution is 0.77 seconds. As you can see, we have now added this to the drawing, as well as the fact that it goes through one revolution during this set amount of time, which she is pointing out right there. Now we begin drawing a diagram of the wheel. We measured the wheel itself, and my wheel, being 26 inches in diameter, should be approximately 0.33 meters in radius, which she is now writing on the board right there. In addition, because we set the rotation at one full rotation, we know that the angle is 360 degrees, or 2 pi radians. Now that the problem is all set up, it's time to finally solve it. Now we will begin by first writing out the known variable dt, which is equal to 0.77 seconds. Second, we will use the formula that was proven to us in class, which states that theta, the angle, is equal to L over R. With some simple algebra, we can rearrange this formula to solve for the value that we actually want to find. So therefore, we can rewrite this as L is equal to theta times R. On the subject of theta, we happen to have another value we can use to solve this problem. We know that in the video, the bike wheel went through one rotation, so that we can say that d theta is equal to 2 pi. Now that we have all our values, we can finally solve this problem. We know that v is equal to dl over dt, which is equal to the second derivative of theta times r over the second derivative of time, which, plugging in our values, gives us 2 pi times 0.33 meters over 0.77 seconds. Now that we have our formula and numbers all set up correctly, simply plug it into your calculator to find that the bike is going approximately 2.693 meters per second. And with that, all that's left is to box our answer. Thank you for watching, and we hope that you'll be able to use the information presented in this video to your advantage.